Hello, Mr. Cookaday. So today we are going to learn how to measure voltage using a digital multimeter. So you need your lab sheet and go through the equipment list. You will need a digital multimeter, digital display. You will need assorted batteries laying around the room, different size batteries. Please don't go out and yank the battery out of your car. You will need an AC outlet. I have the strip here. I recommend using the one on the wall. You will need something to write with, and you're going to have math, so you're going to need calculator as we calculate percentage of error. So the first part, I'm going to go through the parts of a digital multimeter, and you have a picture like this in your lab, and you're going to fill out these parts with the names of each stuff, each part of the digital multimeter. Nice thing about digital multimeters is there's kind of self-correcting. You don't have to read needles. You don't have to worry about scales like us old people do. So, starting at the top, we have the display. That's simply the little LCD screen at the top where we can read what's going on. It would tell us our voltage, resistance, current, or whatever else it measures. Remember, this is called a multimeter. It means it measures multiple stuff. To determine what we are going to measure, we have this little round switch here that goes around to different readings. That is the function switch. That controls the function of it. It should be an off when we're starting, nothing on the screen. Later on, we're going to go to the V for voltage. That's the only one we need to be concerned with today. There are others. The next one with the little symbol on it is for ohms for measuring resistance. We can measure capacitance. We can measure hertz with the correct leads. We can measure different sites of voltage. Actually, with the correct leads, we can measure temperature. All sorts of things can be measured with them. Today, we're going to deal with off and the V. Up top, here in the little corner where my finger is what is called the select button. This is a good one to know because each of these functions here have a sub-menu. To scroll between the sub-menu, you'll hit the select button up here and it will allow you to other things. Voltage today, not big of a thing. However, believe it or not, you can run two voltages. You can run a DC voltage and an AC voltage together. The select button would help you separate so you can measure just the AC or just the DC. That won't be an issue today, but as we go along, you'll often want to check that and make sure it changes the display up here to what you want to read. Last but not least is we have our measuring devices, the cables. These are called leads. Traditionally, we have two sorts of leads. We have a red one, which is the positive, or as we usually say in electronics, the hot one. This will go to where the voltage or the main thing we're measuring is. And then we have a black one, which is called the common, or quite often thought of as the negative lead. On your multimeter, they will plug in down here, and they are color-coded. Over here on this side, you have the red one, and you notice it will have the same symbols up here for measuring voltage, ohms, and so on. That's the hint. You always want to plug the red one into what you are going to measure. So for today's, you'll take the end that's not pointy, red to red. The next one is the common, the one just over there. And it is for whatever we are selecting. Once again, I would take the lead and move it in and plug it into the common. And now our leads are set up. Now, a word of caution. These are little metal tips. They're pointy. Don't stick yourself with them. But when we're sticking on something with voltage, be aware of the voltage. When we're measuring AC, you could get hurt. You could get killed with AC. Just like when I'm plugging in a plug, I don't hold the metal part when I stick it in. I hold it by the plastic part. That's what you want to do here. For safety, you want to hold it above the little wrist. If your fingers are down here touching the metal, you could actually shock yourself. So that is a big safety precaution for today. So now before you go on, you may want to take a moment and fill out this part of the lab sheet, and then you'll go on. The second part of the lab is you're going to take batteries and you're going to measure the voltage, and then you're going to figure out the percent of errors. Now, when you get a battery, it will have a name on it somewhere. These are D batteries, slightly smaller C batteries. We have AAA, AA, watch batteries with fancy numbers, 9-volt batteries, car batteries. They come in all size and shape. As you pick your battery, you're going to pick 3 different batteries and you're going to write the name up there. Now, to calculate percent error, we need to know what is the ideal. Here's a little quick review. This is on the sheet. To calculate my percentage error is I will take my real number, that is what I measure in real life. I will subtract my theoretical. That is what the paper says I should get, my ideal number. I will divide it by my theoretical number. I know that sounds fancy. And I will get a decimal number. To turn it into a percentage, I will then multiply the entire thing by 100. A mouthful, right? Here's what that means today. I will take the voltage I measure, the voltage reading on here, to the nearest tenth. I will subtract it from the ideal. It is written, excuse me, somewhere on the battery. On a D battery over here it says 1.5 volts. So that is my ideal, or my stated number. I called it stated on here. So what I measure off the multimeter, I will subtract from it the stated, the 1.5. I will divide by the stated and times 100. It is here on the worksheet. You just fill in the blanks. So to show you how that works, I'm going to take my D battery. I know my stated is 1.5. This is a D battery, so I'd fill that out. I will take my multimeter. I will turn it to volts, and I get a screen that pops up where I can read. I will set this somewhere where I can read it, and I will take my battery. They're measured negative. That would be the common for black. Yes, I mentioned not touch it with your fingers, but I'm holding this by myself. And the positive end, I would measure with this. When I touch these together, I will get a number appear on my screen. It may shift a little because it picks static up in the air. But to show you, Mr. Cook's got to do a balancing act. This one says 1.572. 1.572 amps. So if I round that off to the nearest tenth, it would be 1.5, take the 7 roll up. So this would be 1.6 volts is what I'm getting. So let me show you the math. My measured is 1.6 volts DC. My stated, excuse me as I messed this up, is what I read off the battery. 1.5 DC. To decide my percent error, I would look on my formula, and it would be my measured 1.6 minus my ideal 1.5 over my 1.5. Measured minus ideal divided by ideal, and to turn it to a percentage, I would times it by 100. So if I whip this into my handy calculator, I'm good at math, but I don't have the time to do this. 1.6 minus 1.5 equals, divided by 1.5 equals, I'll get a decimal number. I'll multiply it by 100 to turn it into a percentage. And I get 6.666666666. To measure it off, the 6.666 would turn into 6.7% error. That means my battery is off by 6.7%, almost 7%. Believe it or not, in electronics we have a big slop factor. That is not a problem. So you would measure 3 different batteries and calculate the percentage. Now, once you're done with that, the last part is to measure AC. Take our same multimeter, turn it to volts, it actually will automatically shift. If you notice by the V, there is a straight line. That means it represents DC voltage. And there is a sine wave. That means it measures AC voltage. Now, our wall sockets are AC voltage. I'm using these here, and they have several parts. I have a picture of this on the ground. When you look at it, the two big important ones are the flat blades. The blade that is bigger than the others is called the neutral. What that is that is grounded back at the generating station. The neutral does not technically carry any voltage on it, so it has 0 volts. Everything that is deadly and gives us power is in the short blade, and that is called the hot. That is the one you have to be scared of. That's the one that can hurt you. Ground is the same as the neutral, except ground is here in the building. Ground is what causes the fuses to blow. It also has 0 volts. To get any voltage, you have to measure from the hot to one of these, the hot to neutral or the hot to the ground. So you're going to try all 3 different ways. You're going to take your voltage meter, you're going to stick it in, and you're simply going to measure from the neutral to the hot and record the voltage. You will then measure from the hot to the ground and record the voltage. If it is a properly wired plug, you should be getting about 110 to 120 volts on that, depending on where you measure it at. Then you should measure the neutral to the ground. You should get close to 0 volts. Sometimes there's a little static depending on where it's at. This is a good way to check if your plugs have been wired correctly so you don't blow things up when you plug them in. So to demonstrate, take my meter, go to voltage. I will take my plug here. I'm going to crank this down so you can see what I'm doing here. I will pick one of my outlets. I will measure the hot to the neutral. Notice I'm holding it by the plastic. And I need to plug it in. Sometimes you got to wiggle them so they touch. Little difficulty here getting them to touch. Boom. If I do this one here, I get between these, I'm getting about 110, so I'll go neutral to positive. I will go ground to hot. That's the small blade. And then I will do the neutral to the positive. 3 different ways, never touching my fingers, and getting a reading. So you can do this on a power strip you know is working, or you can do it on any of the outlets around the wall. Be careful you do not touch any metal so you don't shock yourself, and you'll simply record them there. When you are done, you'll come and have me sign so I know you actually did the lab and you're not copying somebody else's work. So welcome to the world of digital multimeters. If you want to put in car systems, fix electrical problems, do your house wiring, anything that involves electricity, this is the best tool. This is the #1 tool you need to know. Just knowing how to use this properly can actually open up a lot of doors for you as far as employment goes. So feel free to play with it. Look up more on YouTube. There's tons of videos on how to use digital multimeters. We're going to be doing a few more labs, but today it's your introduction to the multimeter, measuring voltage, DC voltage, AC voltage. Have fun with it.